All right. How's everyone doing out there? Welcome to today's LinkedIn Live session, our live stream with myself, Harry McCullum, and Mark Taccolini, our CTO and founder. How are we doing today, Mark?
I'm great, thank you.
Today's topic is unified namespaces. Key concepts, and we're going to be key concepts combining MQTT and OPC UA data. We're going to talk a little, and then Mark's going to show a demo emphasizing these concepts. Today, just a couple quick announcement things. Today is a big day as we officially release our version 9.2. So that should be available. If it's not available now, let's say it's available tomorrow. And we've got some big events coming up next week. We're going to be on live with HiveMQ on one of HiveMQ's monthly webinars. Mark will be on there, and the topic will be designing an edge to cloud architecture for IIoT, and that's Wednesday, November 17th at 10 a.m. And then next week, we're also doing a Tats-Off Embedded Canary Historian workshop. So we're going to dig in deeper and show you how you configure and work with our Tats-Off Canary Historian. We've announced, and that's coming out in our 9.2 version. So that is Thursday, the 18th at 10 a.m. And then also just kind of we'll be also doing some more workshops early December, workshops training around our 9.2 release. So with that, I'm going to turn it to Mark here to kick off today's topic.
Good. And I will start to talk about Unified Namespace. I'll go a little back driving time because to understand the new concepts, it helped me a lot using my previous experience to understand they are pretty much evolution on what we had in the past. So because over the past 3 decades now, we've been working a lot with that similar concept of having some sort of data model in the middle as a key core components, and the data sources, the archiving, the applications in the top consuming the data, and everything has been around real-time data for a long time, but by long time, I mean 35 years. So a little parenthesis for history. I started working with that kind of application in 1986, long time now. And along those 35 years, we have a few generations of technology from DOS to Windows, then Microsoft Foundation classes. And gladly, some products that we created more 10 years ago, they are still brand label and on the markets. And then we went to Tats-Soft to try to leverage a 4.0. And with those generations of software technology, there were also some generations on how you are managing the real-time data over that time. So let's go to our Cliff Notes version. I will start with Modbus. It's still very important because Modbus was the very first abstraction layer around your data. So you have the counts of the registers, and they were not more talking too much about which equipment or which wiring. You could start to have some metadata to define that. Of course, very soon, they found that register numbers don't say much. So we evolved to do tag-based address, to put a tag name to specify the value. And that evolved to user data types, templates, adding more structured data. And finally, we went to asset-centric applications, where we don't think only as much as a data structure, but we think in terms of which assets I'm monitoring that can be composed by many tags and many structures. And you'll talk more a little bit later, but these asset-centric applications, they used to have a big limitation, that they had the requirement to bring all the data to one centralized asset framework. So bring me all the data to my asset model, and then I can deliver my analytics. But what we're trying to look for now is when you have the data distributed across many applications. But anyway, those concepts evolve to what we have now. That's the big data organization. And can you help me some comments how to explain that? What is the typical organization now on the intelligent manufacturing? If you have on the line, Harry, I don't see your speaker.
Yeah, I was muted. Sorry about that. So yeah, I think the key here is everybody is kind of wants to get to kind of this manufacturing or industrial intelligence in the cloud. So that's kind of where this manufacturing data lake comes into play. And companies like us, our strength is, and it has always been, out at, getting the data from the device, basically transforming that data into a form that can be easily transferred to these other applications and the cloud. So we're really preparing things for that real-time data analytics in the cloud. And the unified namespace is, so we can create a unified namespace, but we can also kind of consume and integrate with any unified namespace out there. So I think that's the key, is really this kind of open flexibility at the data source kind of gives you that capability to do to get to the analytics in the cloud.
Exactly. And that data organization, I start with that concept of unified namespace. And I strongly recommend to have some concept of that, the videos from Walker Reynolds. He was one of the best one I saw, really going deep on the concept of unified namespace. And adding my own concepts on top of that, it's not only about have a standard tree definition of your assets of your enterprise connected with in real time with all the different applications. It's a little bit more than that. It's also the ability to have a way so those external applications, they still can be owner of the data, but still being part of that abstracted data model. And we're going to do some real world examples. I will create some real projects in 15, 20 minutes from now. But before, let me talk a little bit about that concept, unified namespace. A very first one is, okay, it's a digital representation of my assets, but what's the difference of my previous asset models I have in the past? Why it's called a unified namespace? Well, first of all, it has or supposed to have the ability to integrate all different areas of the system in a unified model. And it's more than that. It needs to be able to solve some specific challenges that we'll talk about now. One of them is that to be able to consume data that's not centralized, neither in a data center, neither in the clouds. In the next years, we estimate that in industrial automation, 70% of the data will be distributed. So you need to be able to have the unified namespace defined, but dynamically being able to consume the data that's not centralized. And another key requirement, you need to be able to be agnostic on what are your data historians, what are your data servers. So the old concept of trying to create your standard by product names, that's gone. We are now working to create standards based on technology, based in open standards of connectivity. So the new IoT systems, they don't really bother as much what specific vendor you are going to use in each level of your stack, as long they are in compliance with the new and open technologies. And I'll not go in details of all those items. Feel free to do a screenshot if that will be helpful to you. But essentially, the requirements, as explained, should be open on technology, and very important to enable self-service approach, being open in the sense to allow other areas in other applications to consume the data. So when you're publishing, you don't need to worry about that. Of course, being able to be highly distributed, as you explained, allowing hybrid storage, and of course, reliable. And by reliable, I'm not talking about avoiding Windows blue screens, because that's gone for more than 10 years for us that are pure.NET. I'm talking going beyond that. To be reliable, you need to avoid data duplication. You need to avoid have hard code data mappings that when one system modify, you need to start changing links in them 10 other systems. So not only the current application must be secure and resilient, but also the maintenance effort on that you need to minimize. Otherwise, over time, your reliability goes away as the system evolves. And some of the key technologies we are really going deep to support that. Of course, one is MQTT, that was designed, fit very well in that model of Unified Namespace, because on its heart, the MQTT protocol is a published subscribed model, and allows to scale very nicely, because, for instance, in the applications I'll be running today, we are using our TechSoft frameworks embedded broker. When we install our product, we install also a broker. But this broker is mainly designed for testing, development on the edge. When you scale, you can pick up exactly the same application architecture and replace that broker by a cloud tool or by HiveMQ that we're going to have the workshop next week. So the concept of public subscriber and the concept of having that hub, that broker, is really very useful when you go to practical implementation of Unified Namespace. And another concept that we are really among the first ones to bring strongly to the market are the concepts of dynamic tag providers and distributed data stewards. Let's talk about those two concepts. Most of the people here, I'm assuming, is very familiar with the concept that you have a tag name and you map this tag name to an address. But dynamic tag provider is when we have that connection, as the name say, dynamic, without having to create tags. So we are going to show that in a little bit, that we can create an asset view where parts of that view, they refer dynamically to an OPC UA, to a control logics Rockwell device, to a historian. So essentially, you can create higher level applications or even data connectivity gateway applications where you are not creating tags, you are not doing static mapping, but you are allowing to dynamic connect with those providers when creating your main application. And if that sounds too abstract, give me some minutes when we go to practical examples that will be more clear. And with that infrastructure in place, we allow to have this distributed data ownership. So if you try to move to the digital transformation, try to make all applications and all areas of your company following compliance to one data defined by one specific group, it will not work. Each process area, each specific departments, they know their data. They are the ones that are capable to do that proper data definition. So you need an architecture that will still allow each silo to be the owner to define which data it makes sense to share or consume, but they publish that on the unified namespace in a standard way to give visibility through the entire corporation. So essentially, you have an asset model that pick up many concepts of Spark-Plug Blee also. Spark-Plug Blee is an extension of MQTT protocol, but frankly, everything on that specification was with unified namespace and dynamic connection in mind, because they put standards on how to define the topic names. They have the concept to birth and death message to allow the systems to register and go out from the network. They always have the report by exception. So what we did in our framework, we not only leverage all the Spark-Plug Blee specification when using MQTT protocol, but even when you are using OPC UA, Canary Labs, Rockwell, OZSoft, G-Story, or other tool, we put those dynamic concepts in place. So a typical frameworks application now, a key component is that one highlighted where you have your unified namespace or data modeling. That unified namespace can dynamically be connected with all those technologies and others. And that is connected with our real-time engine. On the bottom, on green, we still have mapping. We still have all kind of PLC protocols feeding that data on the past. And the script, the alarms, the historian, the visualization tools, the analytics, we have this abstraction layer that all those tools in blue in the top and the historians, they will access the data through the unified namespace. So if you do an application that are getting data from OPC UA or MQTT and saving Canary or saving Python doing analysis, nowadays it's very straightforward. You don't need to worry too much the details on where will be the data in and out, because you get great applications and you can do maintenance of that applications very easily, doing modifications in that data flow. So let's go to some practical examples. Before I go to product configuration, Harry, if you want to add any comments, feel free to.
Actually, I had a question today, earlier today, from one of our systems integration partners, and I didn't have you to answer it, and so I'll ask you right now. So what's the basic difference between the standard, kind of our standard device drivers and all the protocols we support in a dynamic tag provider? And I think you just talked to that a little bit, but if you could just answer that directly.
Let's explore that with more detail. The key difference, what I'm saying in that static mapping or static binding, what that means. And in fact, I think I will explain using these charts. Typically, in the device drives that we still have, by the way, we are shipping the product now with more than 70 protocols out of the box, and we have 200 more protocols that we have knowledge of the protocol understand the protocol if you need to deploy. But what are all those device drivers in the bottom? You have the concept of creating a tag in Faculty Studio and mapping this tag to the address of the device. Whatever is the Modbus register 4001 or the Siemens data block 10 data words 20, or whatever is the addressing of the device. Even control logics that they have tag names, you map the PLC tag name to the Faculty Studio tag name. So on the device drivers, we had, like all SCADAs and HMI, by the way, that concept to have the tag in the application mapping to the PLC records or to the sensor address that was exposed by the protocol. Okay. We, the dynamic tag provider, we went one step further to allow the displays, the SQL storage, the analytics, to use directly the data models from those tag providers without having to do any mapping, and dynamic. So if I'm getting data from MQTT or OPC UA, if they add one more asset on their sites, my application is self-aware. I don't need to modify my application to start using that additional address. So it's a quite, frankly speaking, a little crazy concept for me that working for 3 decades, always having tag in my mind, that you do applications without creating tags, just like using your data right away. But that's what the dynamic tag provider allows. Okay.
Yep.
And to be clear, most of the projects were still going to use both.
Yeah.
Because in many cases, you want to have the static mapping to the devices because you want to be sure that data will be there. In some cases, you want to do some normalization of names, or you want to organize your data structures. So there are many scenarios why it still makes lots of sense to use the traditional drivers. And as you start to get familiar with those two concepts, we'll see that it will become very clear in one point what part of the application you should do a dynamic mapping, what parts of the application should have a static mapping.
Okay. Yeah. Also, it's all kind of like design side consideration based on your application.
Oh, yes, exactly.
Okay.
And I'm not show today this demo, but just a little hint. If you want to explore more demos later, today I'm going to do another one. But if you go to YouTube and you search for that soft solar panel demo, we have another example of distributed architecture collecting data from main device to a centralized location. And I have another LinkedIn Live where I go in real deep detail of that configuration. Because what I was planning to do today was something different, was to go to our tool, create a new project from scratch, okay, and see how we can, without using any previous templates, not really starting from an empty page, okay, we can very quickly starting to create some applications around the data. So one thing I did put running previously, I put running 2 simulators, which both, by the way, are included in frameworks. I put running this MQTT Spark Plug B simulator, doing simulation of a bunch of devices. And this MQTT simulator is publishing data to this MQTT broker. That's our embedded broker that we have by default. And I put also running this OPC UA simulator. This OPC UA simulator is also included in our distribution. The name is OPC UA simulator.exe. If you look, it will be there, where I'm simulating 2 nodes and 5 devices on each nodes, okay? So I have those 2. And of course, I put 2 simulations running local in my computer. But everything that I'm explaining here is exactly the same with other data sources of remote assets. In fact, next week, we're going to use HiveMQ to do similar demonstrations. And what I'm going to do here, okay, if it was old style system, I will go here and start to creating tags, okay? But because I want to show the new concepts, I go to provider and I will create some new providers. By default, in a new project, we send the canary because by default, you can use canary as historian. But let's focus on the data query now. So I will create a new connection to a dynamic tag provider, and that list will be growing the next few weeks and months. But I will create one to Spark plug B, and I will create one connection to OPC UA. Okay. Well, now I need to select which broker and which server I'll get. So to Spark plug B, I will use by default, it's pointing to this port and the local computer. That's our embedded broker. So no configuration here. If you want to plus another broker, you need to change that URL, and eventually you need to do some security configuration. And on OPC UA, I will ask to discover which OPC UAs I have in this local computer, or you can put here computer name or remote server, and you can ask for search, and the system will search for the typical OPC UA endpoints. That helps a lot. On the past, we have to search that or know manually. Now we have that ability to show the many servers, to know what kind of security they require. So in this case, I'll pick up this one that does not have any specific passwords. So I can just create a default certificate to that. So without having to know much about OPC UA security, that can be very complex, I can just create a default certificate map, and I have my OPC UA connection created. Okay, that process, by the way, was very simplified from our previous releases. Anyway, now I have those 2 connections. Before I start doing my application, I can right away to browse. So here I can see what I have in my dynamic connectors. So I see in my Spark plug B, I have some data model defined here with the name of those switches. In the name of those switches, I have some panels with some data, which, by the way, is the one we use for the solar panel demo. Here on the OPC UA, we have the data our simulation is publishing, and I have some values there. Okay, so the data's there. I have already accessed the data. Let's start to do some top level application around that data. So I go to my asset model. These tags, a built-in tag we send only so you have some information about the computer CPU. It's one thing we are doing this new release. But anyway, what I'm going to create here is my asset model. So the purpose today is not really talking too much about asset modeling, but here you can use as SP95 specification, or you can create trees with any and how many levels you want to have. The name of each level can be the name of each site, or can be the name of each line. So there are many published standards on how the best way to organize your data. But for now, I'll keep simple. I'm just creating those nodes there. And what I'm going to do now, okay, we can create tags inside our application as usual. And our tags can be very powerful. I can create, for instance, a tag of type data table. So if I want to move data from a query, from a SQL database, and expose that to a unified namespace, we can do very quickly. By the way, that will be another demo in the future, how to move SQL data to the unified namespace. But for now, I'm not going to create any tag. What I'm going to do is just insert a dynamic asset. So when you go insert asset from provider, you can browse on your providers, and this data will be whatever we have in that broker right now. So if someone puts one more seat there, I'll be able to use that seat right away. So let's say to my application, I want only to expose to this application the data from Madrid. So I'm going to pick up this piece of the hierarchy Madrid, or I can go to a specific pair. In this case, I'll pick up Madrid. So I added in my asset mod that under my level 1, and my level 1, let's rename it to European capitals or something like that. So under my level 1, I added dynamic to Madrid. And to avoid to show this beef pack, MQTT, Splackbook B, Group ID, Madrid, I will put here a display text Madrid. So on my UI later, instead of showing the physical address of that tree, I have only that name. But what's important in my asset model, under European capitals, I have this data. And what I'm showing in asset model in our products are not tags we had to create. We're just using right away whatever I have in that reference. The same way in my level 2, that I will rename it to other important data, whatever that is. You see, I'm not very creative today for names. But here I'm going to go to that OPC UA, to my node 1. And let's say my node 1 is some sort of cool data that we need, okay? And here on this tree, I have the data that was exposed by that specific VLC nodes. Now that I have my very simple unified namespace, of course, that's a very simple example, please. So be nice with me. The idea is just to keep simple, so we focus on the concepts. I can go to my screen and start to create some displays. I could create analytics, alarms, anything, but let's go to displays that's more visual. And so I'm going to put here an asset control that by default will show that assets. I will show here some data on the selected asset table. I also want to show a little trend chart of the selected variable. And here I want to show some, let's put here a better color. Here I want to show the name of the selected assets. And here I want to show the value for that selected assets. And here I want to do a bar graph with that data. And let's put some roundings on that shape to be a little more beautiful, okay? So a very simple display. And let's do the map of the data, okay? This asset control is a built-in control that you can put here any string variable to give you the name of the selected assets, okay? But in this little demo, to be quicker, instead of creating a tag, I will pick up, we have a predefined tag called trend charts that typically we use to dynamically select the panes of the charts. So I will pick up to map directly. So the selected assets will be feeding the trend chart. So I just need to go to the trend window and say this client.trend chart. It's a predefined variable of namespace clients. It means I can have two displays open at the same time with two different select assets. But this trend chart will map it to this built-in variable client.trend charts. And the first pair will be from these objects. Here, to show which object was selected, I'm just going to create a text output with that same variable. It does not be client.trendchart tag name. You can put any string tag here to be clear. Okay, I'm just using that one to save me 1 minute of YouTube time. So this will be the name of the selected assets. To show the value of the selected assets, there is a little syntax you have to learn. Because if I put that again, that's not the value of the selected asset. That's the name of the selected assets. So we have a new method in 9.2 called assets. So if you put assets, open parentheses, you are showing the value of that asset. By the way, I'm using a tag. But if you want to do an application that hinges fields, you go to the OPC UA, tag OPC UA 1, and you pick up this variable, and you show this specific variable on your UI, you can do also. So in this case, I did the mapping to show one specific data that I'm browsing dynamically from my data sources. So the syntax is the same, but I don't want to be one specific asset. In this case, I want to pick up whatever assets is in that variable. It is in my client dot trend charts dot pans. In this case, I want to dynamically show the value of this specific tag. And you see one thing that's very important, even with dynamic features, everything on that soft frameworks, like the trend charts, the alarm, that concept of dynamic point, a tag name, it will work with the dynamic data as well, okay? So everything we had on the past, we still can use dynamic data. Here in this bar graph, I want to create a bar graph here with some sort of nice shading. Would be pretty much the same. But instead of putting a tag defining the application, I'm asking, give me the data from these assets. And the asset is something that I'm dynamically selecting. Okay. Any questions on the configuration, Harry, before I put that to run?
No.
Okay. So let's go to run. I want to run this application test modes. Okay. And I will switch the ports here because I think I had already another application running test mode. So I'm putting the application to run. And let's see what we have. I know I have the data because on the configuration tool, we can browse the data and see the values of the data sources. Now I'm starting to do some custom user interfaces around the data. So here I have my tree, and you see in this tree, the user does not really care where the data is coming from because I'm looking, oh, I forgot to put here the text display, I'm guessing here. I need to go back and put the display name there. But anyway, here I have the data that's from the MQTT, okay? And I see the application is not very nice because the data is okay here, but this label is terrible, and the scaling of that variable not good also. So let's do one thing. We don't need to stop this application. We do have online configuration. So I can go here and to switch the position of that to be on the bottom. I go here to do that scaling a little bigger because my random data simulation is saying data that is really wide range. And I review here some of the names I have on the tree. And, oh, the data is right. I put here to be cool data. Oh, I know what was the problem. Here on these objects, you can select if you are going to show the real address of the data or the display text. So when the application was running now, I was showing the real data search for this subtree. But if you want really to hide that information from the operator, you can ask to use the display text instead. Okay. So I did those modifications on my display, and I go back to the application that's running. And because we have online configuration, that's there. So some people sometimes ask, oh, why you have a runtime and a configuration environment? Do not be much easier to do the modification, the runtime? Not necessarily. I can talk about that in another presentation, but there's lots of benefits to have the isolation between the execution, the runtime, and the configuration tool. But that's not really any limitation to speed up the configuration, because if you want to do modifications with the runtime connected, here is where you do that. So when you have the runtime connected with the configuration tool, you do your modifications and your screen will reflect right away. But let's put this object here. So you save and the object is there, okay? But it's useful to have that isolation between both. So here I have my cool data from OPC. I have my data from the panels, and here I have my charts. Oh, and it seems I forgot to map these data grids. So let's go back to data grids and map the data grids to be also the selected assets. So, and I use auto create in the columns. So I will not define which columns I'm going to show. I'm just going to show whatever I have in the selected objects. So if I select now here Madrid, this tree is showing the children. If I select panel, this tree is showing the properties. And definitely much bigger will be better. So here and I just not requested to select which columns. So he's putting way more columns that I need. Okay. So let's do in that way. So a little more friendly now, the UI. Okay. But that's it, Harry. That's an example on how you can, of course, you can now put more advanced UI. You can create symbol templates. You can create dynamic templates that you populate automatically 1 or 5 panels, as we did on previous demos. But I thought that would be interesting and important to start one project completely from scratch and do some basic UI and data modeling in just a couple of minutes.
Yeah, I think that gets the concepts across. We did get a question a little while back. Maybe we can hit hit on that and see
Yeah,
if
we
anyone.
can go for questions. In fact, I think I will stop my sharing screen so I can have some face-to-face.
Yeah.
I am old style. Even through YouTube, I like to be face-to-face, whatever that means. So let's go to the questions now.
Yeah, basically it was, please explain how the dynamically created tags from the edge fit into a central UNS data model.
Oh, that's a very good question. And in fact, to reply that one, I think I'll share again my screen.
Okay.
Because I happens to have in this virtual machine one project we do exactly like that. So this project here that have my computer is a project where we have a configuration, get data from the edge and send from a centralized location using tag providers. So I can reply just showing the configuration. So in this example, we have two tag providers, Canary História, and this one, the name's a bit long. They call Canary História by MQTT, but it's pretty much an MQTT provider. Okay, so in this application, we are using to get data from a MQTT provider. So we have this data from the provider. And what we're doing in this application, we are using our historian tool to send that data to a remote historian. So one thing we also did improve is in 9.2 is that when you create a historian targets, we can very easily pick up between remote SQL databases, Canary Labs, will be very soon add the ability to select GE or Pi or InfluxDB. So the people that know us, they knew that we have that concept of do store and forward to our local database. But now we grow this concept to be any kind of external provider. And each table, you can select if it's going to Canary or if it's going to some other place. So in this example, let me complete the configuration. Let's say I have Canary server in this other computer. Or I can publish a remote MQTT broker. In that case, I will keep the local because I don't want to broke too much my demos after all. But essentially what I do in this case is here we map it all data that are reading from this provider, starting group ID, to send to Canary. And what's nice about this configuration, whatever they put in the broker under group ID1, I'll be sending to that remote historian. Okay. In this example, I'm setting all this subtree to a remote historian. But to be clear, it can be to a SQL database, it can be to another MQTT broker, or it can be to another application that has some sort of open protocol, okay, or OPC UA target for that matter. That's one example of configurations. Only 2 lines. I'm getting data from MQTT and sending to a centralized archive.
Okay.
Other questions, Harry?
When can we download version 9.2?
I am in this meeting. It's not showing the image, but our marketing people is here in the meeting, also behind the scenes, and they're putting that link online in some point today. Okay.
Yeah, at the end of the day.
If you fill the form request downloads, if by any chance we still receive the 90.1 link, we'll make sure to send you tomorrow the 90.2. Because as we speak, we're changing the G4 link from 90.1 to 90.2 if you hit our site request download. So feel free to do that right now. If by any chance it's still 90.1, we send tomorrow the 9.2 to your email. And when you install 9.2, you can enable to install Canary Labs also. If you have Canary Labs or computer, you should go to custom installation, and you don't need to install Canary. You use the Canary you have your computer. But you don't have Canary, by default, you have the installation for Canary Labs. So please do that. And you have a button to request the temporary license for Canary for 1 month. And also another button to send us an automated mail to enable the 500 tags at no cost. So start of 9.2, we have that as part of the installation. You just need to request to receive that additional benefits on Canary Studio.
All right.
I think that's it for today. We are almost in our time, Harry.
Yep. Okay,
so
Mark.
Thank you guys very much. And if you don't have think of a question now, if you have any kind of scenario that we need to create a unified namespace, you need to do data transformation before you publish. You need to do front end at the centralized station, or you need to do the edge. We have now piece and parts to your full architecture. Okay, thank you very much.
All right, thanks, Mark, and we'll see everybody next week. Just a quick reminder, Wednesday we've got the joint presentation with HiveMQ, 10 a.m. Central, and then Thursday we have the workshop with the Tatsoff Canary Embedded Historian, Thursday, November 18th, 10 a.m. And should see 9.2, at least I'm going to under commit and over deliver by the end of the day. So thanks again. Thanks, Mark. And we'll talk to everybody soon. Take care.
Bye.